Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be talking about arithmetic without numbers. Okay, arithmetic operations without numbers. As a matter of fact, all the arithmetic operations were already in place long before numbers came along. That means that everything that you do with numbers, whether they be uh, whole numbers or fractions or anything, was already established in Book 5 of the Elements of Euclid using only one proposition, that is, proposition 12. So today I'm going to show you how you can perform the operation of subtraction using only the ratio of two magnitudes and how you can define the difference between two ratios, because all the arithmetic operations came long before numbers and worked on ratios of magnitudes. So I'll give you an example now of how that's done. I said now, that's a South African phrase. What I mean is in just a moment. Now, if you do a search for these, you'll find many sites, and they're all garbage, by the way. Every single one of them except mine. Unfortunately, I don't see mine coming up here even in the first page. So that's very unfortunate. But in anyhow, let's look at one of the links that are gotten from here, which is the PhotoMath link. And it says that arithmetic operations are the building blocks. Well, yes, they sort of are very important. And it says that the fundamental arithmetic operations are typically thought to be addition, subtraction, multiplication, and division. There's a problem with that order, by the way. First of all, subtraction should come before addition and division before multiplication, okay, because the correct order of the operations is subtraction, addition, division, and multiplication, because from subtraction we get addition, and from subtraction and addition we get division, and from division we get multiplication. So let's see now in this I didn't mean to do that or that. Let's see how we can find the difference between two ratios. So supposing that we have a ratio like that and another ratio like that. Okay, the only way we can do arithmetic on these ratios is if they have the same consequent, okay? Now remember, we're not dealing with numbers yet. These are just lines. So how can we do this? Well, we can place this antecedent part here, along here, and the consequent part, which is this part, along here, right, like that. Then we can do the same with this ratio, okay, by placing that antecedent there, like that. Should have meant to do that in green, like that, and then placing its consequent like that, okay. And then to find a ratio that will be equivalent to this ratio with this consequent, what we do is we connect this green line and the magenta line like that, and we find a parallel line that runs like that. And then, of course, this distance here will be the new consequent. And now the consequence, or the new antecedent. The orange one will be the new antecedent, and these will be the same consequent. Now, once these are the same consequent, the difference is very easy, isn't it? We just take this guy, okay, this gentleman here, and we know that that black part, this black part here, okay, this black part here is the difference, right? That's it. It's as simple as that. So now I've shown you how to find the difference between two ratios without using any numbers whatsoever. And by the way, this is 100% correct. What I mean by that, it means that if you follow this procedure exactly, what you'll have is the resultant difference to 100% precision. That means typically that you could say square root 2 minus pi, or pi minus square root 2, or any other operation you want with exact precision. That means that this line here will have no error whatsoever. That's your result. That will be the difference. Okay, so you use the method that I showed you here. Okay, and that's how you find the results. So let's recap on this, okay? Let's recap. So, first of all, I said we have two ratios, right? Let's do that again. Here's one, and then here's another one, like that. And then we have another ratio over here, say like that, and like this, right? Okay. Then we could draw two little dots in between here just to make it look correct. These are two ratios, yes? Now we can, because the consequence, if the consequence were the same, it would be very simple. We wouldn't have to do anything. We could just take this guy here and measure the difference like that. But if the consequences are different, then we have to convert either this ratio here to have the same consequent as this one, okay? Or we have to convert this ratio to have the same consequent as that one, all right? So that's basically the trick. And then once you got the same consequent, like I showed you, if you have a system of displaying it like this, and you represent the antecedent, this red antecedent along the y-axis, and the blue one, this blue one here, I wanted that to be red. Then the blue one along here, like that. Okay. Similarly, the green one, like that, and the magenta up, I want that to be green, and then the magenta one, like that. Then all we do is we connect these two. Like, let's say the green one is there and the magenta one is there. Then we connect the green and magenta like that. Yep. Okay. And then we just simply find a line parallel to that one, which is like that. And this little distance here, this little distance here is the new antecedent here, okay? So it'd be this and this, okay? So now it would be easy to find the result, wouldn't it? Because all we do is we take this guy, oh, didn't mean to do that. Take this guy like that, superimpose, grab a compass, and then we know that the remaining part, let's make it black, this part here, is the difference. Okay, that part is the difference. Does that make sense? Okay. So that's the first part. And in the second part, I'll show you very quickly how to do the sum. And then I'll show you how to do the quotient. And finally, the product. But now, why can't we say what this guy says here in his uh, site, that addition is first? Why can't we say addition is first? Because simply this, look, we've got the four operators. Difference, didn't mean to do that. Difference, let's just clean everything. Okay, we've got difference, sum, quotient, and product. Okay, so all of these are defined in terms of difference in that order. Okay, exactly in that order. You can't define quotient from product. Okay, so now the thing is, you can say a minus b, and you'll have an answer. Okay, you cannot say that, for example, to define difference from sum, that you have this. And you know why you can't say that? Because then you've already used subtraction in its own definition. Okay, so you cannot say, goodness, you cannot say this to define difference. Okay, to define difference, because you're using it in its own definition. See that? Right, so now that I've convinced you that you can only have sum from difference and not difference from sum, you'll see why in the next step you can only have quotient from difference or sum or both, okay? But you cannot define multiplication until you've defined quotient. All right, so we'll look at that in the next video whenever I get the chance to do it. I'm John Gabriel, and this is a new calculus channel. If you're not already a subscriber, become one. Join my members only channel for a mere €4.99 a month, and you'll be good to go. Till next time, goodbye.